The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.
Welcome to AI for Good, the leading action-oriented, global and inclusive United Nations platform on AI. Organized by ITU, in partnership with 40 UN sister organizations, and co-convened with Switzerland. The goal of AI for Good is to identify practical applications of AI to advance the United Nations Sustainable Development Goals and scale those solutions for global impact. In today's session, we're counting on you to use the live video wall feature to ask questions and post comments to help create an engaging discussion. We encourage you to stay until the end to chat, connect, ask questions, and network with our distinguished panelists and world-class AI experts in the neural network. It is now time to kick off the session and welcome our first speaker. The floor is yours.
Hello, everyone. Good morning, good afternoon, and good evening, depending on where you are joining us today from. Welcome to today's session on GeoAI Solutions for Sustainable Development. We'll be discussing about the Handbook of Geospatial Artificial Intelligence. My name is Rohini Swaminathan. I'm the head of the Geospatial Support Unit at the United Nations World Food Program, and it is a true honor for me to introduce you all to a new episode in the GeoAI Discovery Series. So this series was launched in the beginning of 2022, and we discussed GeoAI applications and policies, ethics, and the future of GeoAI for Good. Thematic sessions included climate actions, spatial digital twins, energy, ecology, agriculture, water and food systems, health, and more recently, we are focusing on GeoAI and education under the leadership of the curator of this series, Maria Bravelli. If you missed some episodes, don't worry, you can watch the recordings of those events on YouTube or on the neural network to which you are connected right now. Without further ado, let me introduce to Maria. She is the professor of GIS at the Politecnico di Milano and member of the School of Doctoral Studies in Data Science and Roma La Sapienza. Amongst her many activities, Maria is also the vice president of the Commission of Geospatial Information of ISPRS, chair of the UN Geospatial Information Management Academic Network, and also the co-chair of the United Nations OpenGIS Initiative. I'll now give the floor to Maria. She'll introduce the speakers of today's session and co-moderate the session along with me. Over to you, Maria.
Okay, so thank you so much, Rohini, and welcome to everyone. Welcome back again to this fantastic and amazing series about GeoAI. I'm very excited today because we have a lot of guests presenting this fantastic handbook on geospatial information. So we start in the beginning with the first two speakers, with asking them some questions, general with respect to the handbook, and then we'll enter into some details of some chapters. So I'm very glad of introducing to you Song Gao. Song is an associate professor and the director of Geospatial Data Science Lab at the University of Wisconsin-Madison. He holds a PhD in geography at the University of California, Santa Barbara, and a master's degree in cartography and GIS at the Beijing University, a bachelor degree with honor at the School of Geography, Beijing Normal University. His main research interests include geospatial data science and GeoAI approaches to human mobility and social sensing. He is co-author of 100 peer-reviewed articles in international journals and conference proceedings. He is co-PI of multiple research grants from NSF, WORMS, Microsoft, AI for Earth, and geospatial industry, and the recipient for various honors and research and teaching awards at national and international levels. He serves as an associate editor for GIS and Annals of GIS, and editorial board member for Natural Scientific Data, Scientific Reports, Geoinformatica, Transaction in GIS, and CA-GIS. He is one of the lead organizers of for the AAGI symposium and on GeoAI and deep learning, GeoAI workshop at the ACM 6 Spatial and GeoAI webinars and at the CPGIS. So very welcome, Gao. But we have also another person for this part of our event with Samantha Arundel. Dr. Samantha Arundel is a research geographer in the Center of Excellence for Geospatial Information Science at the Geological Survey, at the US Geological Survey. She also fills the role currently of research director of the CEGIS. Her research focuses on GeoAI, particularly automatic terrain and other map feature detection and recognition, and using GeoAI to integrate spatial analysis. She headed the development team in the automation of the 3D elevation program as it superseded the national elevation dataset. Sam has a special interest in operationalizing GeoAI research. Before joining the US GIS in 2009, Sam was an assistant and then associate professor at the geography at the Northern Arizona University in Flagstaff. Oh, so very wonderful bio for the two of you. So congratulations. And now I want to start discussing about this super interesting handbook that you are proposing. So first of all, my first question that can be for Gao is that one, Gao. Can you provide an overview of the key topics covered in the handbook and how they contribute to advancing the intersection of geospatial analysis and artificial intelligence?
Sure. Thank you, Maria. Yeah, it's my great pleasure to join the ITU AI for Good webinar about GeoAI discovery. And now I'm going to share some slides about this handbook to have an overview. And can you see my slides right now?
Yes.
Okay, yeah. So in this GeoAI handbook, it is basically include the 4 section, and we follow by a review of the historical roots, and then moving on to introduce the fundamental, very important and latest GeoAI method development, and then we move to how those GeoAI methods can be applied into various applications. And then final section, we conclude with some future perspective. So I'd like to present you, some of the content, because it's not only us, the 3 editor, myself and Dr. Injie Hu and Dr. Wenwen Li, but also about 100 authors from the globe. So this is why I want to present some of those content briefly here. So for example, in the historical roots, in addition to our quick introduction, we also have Professor Helen Kaklas and Professor Krzysztof Janowicz, who are top experts in the AI in geography and GeoAI. So they share their high-level overview as well as the deep thoughts about the philosophical foundation of GeoAI. So here is the some of the 4 rooms about the hand in hand between AI and geography. we have witnessed the four booms. So from 1960 about symbolic AI, in 1980s about expert system, and after 2020, it's recently it's about the machine learning model. So here you can see a quote from Professor Helen Calculus. So it's not often that geography is touched by a development having the potential to affect substantially all of the practical, technical, methodological, theoretical, and philosophical aspects of our work. So you can see her excitement even back into 1986. So now such excitement continue with the new development. And one of the great challenges in the development AI and also GeoAI is actually linking to the UN Sustainable Development Goals, such as the 13 climate action. We want to reduce carbon emissions. However, there's a big challenge about training those large AI models. So here you can see that by training a transformer with 211 million parameters, this training process costs almost 5 US standard vehicle lifetime carbon emission. So this is actually very significant, serious benchmark. So if you think about the new like GPT or other large language model or foundation model, there's even more of their carbon emission and energy consumption and water consumption. So that's really important. And as researcher, also those companies developing those large models, we need to think about this consequences to the sustainable development goals. And in the second section, we have those deep roots, also those important methods such as some of the deep neural network, knowledge graph, also the one later Dr. Lee will present about the focus on spatial image processing. And Dr. Ma has introduced the spatial representation learning, which are also building blocks for the GeoAI. And later, Dr. D. Zhu will present the intelligent spatial prediction interpolation method, which are also very innovative methods. And we also have some novel methods about how to address the spatial heterogeneity in deep learning model and the fairness. Also the expandability, as well as last but not least, Dr. Inje Hu will later present how to evaluate the GeoAI model from not only the traditional cross-validation, but from the spatial aspects. So here, just a quick snapshot, but you can definitely check out the book for more detail. For example, how to develop spatially explicit AI models and how to utilize deep neural network to do the location encoding, such as points, polyline, and polygons, which are very important building blocks for the GeoAI model. And also how to utilize different explainable AI models and to explain the GeoAI results. So in the third section, in the GeoAI applications, we definitely cover a lot of GeoAI applications ranging from transportation, humanitarian assistance, disaster response, to public health, agriculture, and urban sensing. All those relate to the sustainable development goals. And for example, this is the example about the natural disaster responses, which is highly relevant to the sustainable goal of 11 about how to maintain or develop the sustainable cities and then the resilient communities. And lastly, we have also different groups to share about future perspectives regarding the reproducibility, replicability, privacy, ethics, or humanistic future about how to keep human and community in hand, as well as some of the future thinking about knowledge graph, as well as other high-level thoughts. So that's my brief introduction about the handbook. I will stop here.
Dr. Gal, thank you for that excellent introduction. GeoAI is a rapidly evolving field. Every day there is something new. A new article comes in, works with new technology all the time. How did you ensure the handbook reflects the latest advancements and trends?
Yeah, thank you, Roshan. This is an excellent question. So for us, you can see that it's not only very small number of people. It's actually we joined the forces from many institutions and then the countries worldwide. And the process the editor did was we try to identify and then invite the experts who actually not only doing their GeoAI research, but also actively engaging with the GeoAI community and publish the state-of-the-art works. So then we can invite them to contribute their not only the new thoughts, but also the overview. So this is a process we did to ensure actually can capture this fast evolving field.
Thank you, Gao. And I have also a question for Samantha. Probably, Samantha, you are the right person for answering these questions. So I want to understand in what ways do you believe GeoAI can address pressing global challenges, such as climate change, urbanization, or natural disaster response?
Great question, Maria. Thanks. Well, as you know, GeoAI is a sophisticated tool for analyzing lots of geographic data to identify patterns and trends. And so in that way, we can use it to help predict natural disasters like earthquakes and floods, which can enable us to proactively prepare and respond to those disasters. In urban areas, GeoAI can help us to optimize infrastructure planning by, say, considering population density and other kinds of factors that play a role. GeoAI also can play a critical role in monitoring indicators of climate change. Some examples are deforestation, rising sea levels, and during emergencies, it can help promote and prioritize response efforts by assessing damage and identifying areas in need of assistance. And finally, as far as environmental conservation, it can contribute by monitoring biodiversity and habitat health. So altogether, the tool has great potential, particularly in this ability to analyze patterns and trends in large geographic data, which has always been a challenge to us. Thanks, Maria.
Thank you so much. So I don't know, Rohini, do we have other questions?
I do have one, Maria. Perhaps I could pose to Dr. Gao. So, Dr. Gao, AI has been used quite as a buzzword for a while, and we already know there is a lot of potential. But it is hard for a general public, even practitioners, to be able to kind of focus on some of the case studies and understand what are the practical applications of GeoAI. Can you give us some examples from the book, focusing just on the practical part, how it can be used?
Yeah, thank you, Rohini. And there are definitely many exciting case studies, as I just quickly reviewed. But one of those definitely in the following presentation, you will hear from Dr. William Lee, and then also Dr. Samuel is also the co-author from how to utilize the GeoAI method to analyze those, for example, large-scale satellite imageries from USGS, as well as one of the chapter, like chapter 11, about how to extract those features about maps and from those historical collection. So which is a very challenging task, especially how to think about you want to extract features, but also align with the contemporary vector data, for example. So that's very challenging task. So this is why in this handbook we have those many exciting case studies. But I will definitely left the floor for other speakers. They can share the case study later on. Yeah.
Oh, thank you so much, Gao. Thank you. And yeah, I believe that we will have a bit of time also in the end for if we have other questions, because now I want also to introduce the next speakers who will present some specific chapters that, as you said before, Gao. So specifically, we will start with Dr. Lee. So Wenwen Lee, who is a full professor in the School of Geographical Science and Urban Planning at the Arizona State University, where she leads the Cyber Infrastructure and Computational Intelligence Lab. Her research interests lie in the field of geographic information science, focusing on cyber infrastructure, big data, and GeoAI for data-intensive environmental and social sciences. Her work has found applications in various scientific disciplines, including polar science, climatology, public health, hydrology, and urban studies. She has received research support from multiple funding agencies, such as National Science Foundation, the United States Geological Survey, and Open Geospatial Consortium. And she got a lot of awards, a long list of awards, but there is no time to read all of them. So I give you the word because I'm very curious of knowing about what you have to say about GeoAI for spatial image processing.
Thank you, Maria. Thanks, everyone. Today, I'm going to introduce chapter 5, which is one of the methodological chapter on GeoAI for spatial information processing. My co-author, who's also the lead author, Dr. Samantha Arundel, is also here with us. So I would like to give you a brief overview about this chapter. So I think this is very interesting because we have a review about the origin of image analysis actually date back to 1820s and 1830s. So for any of you who are interested to see how image processing has evolved in the past 200 years, I think this is a good chapter for you to get the information about. And then we talk about image processing in the spatial realms and also in the AI realms, which is super exciting because GeoAI has brought a lot of the revolutionary breakthrough for image analysis and for addressing a lot of these critical environmental and social science problems. And then we go on talk about the GeoAI specific methods and the challenges. So we talk about the challenges in training data annotation, the challenge of spatial scale, and the challenge of image resolution and data accuracy, as well as the challenge in space and time, because we not only have the static object, but a lot of the phenomena actually goes through the spatial temporal changes. And then we talk about a few future research that are closely related to image processing, like how we can incorporate geometric algebra into AI modeling, and how to combine GeoAI with physics-based models and use the knowledge as a constraint to guide the future AI model development. And we also touch based on AI ethics, which is another important topic. So origin of image analysis. So I think this dates back to, again, 200 years ago. In the 1830s, cameras has become an essential tool in laboratories and also on geographic expeditions. So you can see from the left-hand figure, this one shows the Anna Atkins published her botanical study of algae in the 1840s using the type images. And the right-hand figure shows Dr. John Wesley Powell's expedition to the Colorado River. Dr. Powell is the second director of the USGS. So in his expedition, what he does is he brought not only scientists, but also a photographer on board to take a lot of cameras during their adventure on the Colorado River. So having taking a lot of pictures, what he aimed to achieve is to secure the truthfulness during their trip. So when we talk about the spatial information processing, you might ask, what is spatial information, a spatial image? There are so many different kind of images, but broadly, you can consider any images that contain spatial information. So I just list a few examples. So for example, the remote sensing images coming from Earth observation satellite, coming from drones and other kind of sensor observation networks. And the second type is topo maps, for example. USGS has historically and also currently hosting the US scale topo map, which contains a lot of these large scale details and quantitative representations about these terrain features, their extent and also their name. So usually they will have contours on each images to show you the elevation changes. And another type is digital elevation model data, the DEM data. So instead of capturing the optical information or spectral information, the DEM data captures the vertical changes, the elevation changes of a terrain. And the street view images, which has been widely used for analyzing the urban environment and urban climate. So in terms of the spatial information processing, like a breakthrough methodology is using GeoBIA, the geographic object-based image analysis, which, as you can see from the below picture, it really analyze the images from a pixel-based to an object-based. So through this multi-scale analysis, you can identify not only the image regions which are similar, but you can also classify what the image regions are about, whether they are trees, they are buildings, or other kinds of natural and man-made features. And then in the GeoAI domain, so we know deep learning has been advancing so fast, and it's almost a perfect model for dealing with this structured data through like a convolutional processing of hierarchically extracting important image features, as compared to the traditional like a multi-layer neural network, where you really need to go from the feature instead of the raw data in order to analyze the important information from images. And in terms of GeoAI specific methods, there are so many that has been introduced in our GeoAI book. But one of them I want to introduce is the beauty of spatial analysis and the GeoAI is we're analyzing the changes on the Earth's surface. So there are so many different data sources that captures what's happening on the ground. And based on the same geographical form, what we can do is we can stack multi-source of geospatial data to allow us to gain a more comprehensive picture about what's happening on the ground. So I'm just showing you an image data set that we have produced. So that's a combination of not just a single satellite imagery, but satellite imagery plus hybrided DEM data and its derived parameters. So our goal is for this different type of features, by adding this different sources of data, we can actually see a substantial increase after adding multi-source images. So this example shows the added value of leveraging the power of multi-source geospatial data in GeoAI research. And we also talk about what are the challenges. So training data annotation is certainly a challenge. And this shows the Bachelor Canyon in Montana. If you just take a look at these images without expert knowledge, it's very difficult to identify its actual extent. And another challenge is a scale challenge. You can see at the proper scale, we will be able to see the entire features, but when we zoom in, we will not be able to see the entire feature. And this is another challenge for resolution and the data quality. We are actually trying to identify a kind of feature which is a landslide. So on this vegetation index data, which shows greenness of the vegetation, we can actually see a pattern change within this extent. But for the DEM data, which captures the vertical changes, if this spatial accuracy is not good enough, we can rarely see our objects in terms of from this data set. And we also talk about the spatial temporal challenges. A lot of the features are actually going through temporal changes. They come from small, but gradually grow in terms of their size. So how to capture these changes from the time series of images is another challenge. And then we talk about future research in terms of integrating geometric algebra. Like currently, there is the new advances in the feature embedding. And our co-author, Dr. Mai, in chapter 6, talk about this exciting area. And another one is how to integrate GeoAI in the hydrological and the fluvial system modeling. There's another very exciting space to explore. And then the third is how to integrate geospatial knowledge, like spatial heterogeneity, into the spatial explicit modeling. Our co-author, Dr. Xie, in chapter 8, specifically mentioned about this. And I list a few references here. As you see, many of these are from our handbook, and we welcome you to read this chapter because they are all interconnected and super exciting advances in this field. Thank you.
Thank you so much, Wenwen, for this very nice presentation of the chapter. Unfortunately, we don't have time for questions, but I suppose that people can contact you if they have questions, and you are very glad to answer to them. But let's go very quickly to another chapter, the presentation of another chapter, which will be presented by Dr. Di Zhu. He's an assistant professor of GIS science in the Department of Geography, Environment, and Society at the University of Minnesota, Twin Cities. He leads the Geospatial Data and Intelligence Lab. Before working at that university, Dr. Zhu was a visiting researcher at the University College London. He holds a PhD in GIS science and bachelor in GIS and bachelor in economics, all from the Peking University. Dr. Zhu research bridges spatial statistics, GeoAI, and social sensing. And also in this case, he has a lot of awards, but we don't have time to mention. There are too many. Congratulations to you, and I give the word to you.
Okay, thank you, Maria. Thanks for the introduction and coordination. I feel super excited to participate in our AI for Good webinar on this GeoAI for Discovery and share some content from the newly handbook of GeoAI to the wonderful broad audience of our ITU. So I'm going to use the next 10 minutes to lay out the logic and some key content we have tried to deliver in this book chapter 7, which is titled as Intelligent Spatial Prediction and Interpolation Method. So in this book, we talk about spatial prediction. So what is prediction in general, right? Regardless of geospatial context. So we might use this example as in a social scenario where there are many people and people are connected somehow. So we would need to measure and understand, for example, these relationships among the people so that we can somehow infer and estimate for certain group of people or individual people those unknown characteristics. So this is the general logic of the prediction, which is straightforward. So spatial prediction is exactly the same as we need to quantify the relationship between locations in terms of their some geographic concerns, such as the proximity, similarity, context, interactions, etc. So as we could predict unknown features at some target locations. This is a very common task in spatial analysis and modeling, especially when our observations are relatively sparse in the geographic space. For example, the limited number of the monitor station of air pollution, or the lack of survey data or high resolution data on disease spreading. So despite this very popular saying that we have extensive geotech data to understand the world from a data-driven perspective, researchers still found that we are facing the challenge of incomplete spatial data, either in terms of limited observations or incomplete attributes and features, or even the mismatch of data scale you collected versus the target scale you are going to work on, and temporally speaking, missing certain time snapshots of the data for sure. So without novel spatial analytical models, especially prediction methods that are enriched by AI, we think it's never possible for us to fully utilize the rich data for a more accurate and comprehensive spatial understanding. So in this book, here is an illustrative diagram included in the chapter that we want to summarize on the typical workflow for spatial prediction. That we need to first collect data samples based on a certain spatial representation. Keep in mind that these are usually the incomplete observations as shown in these dark circles here. Then we would model and derive the complex geospatial relationship that could benefit our prediction. So finally, we can use this derived knowledge for the prediction of a certain target variable so that we can create a more comprehensive mapping and understanding of the world. So traditional methods, including the family of spatial interpolation and spatial regression and many others, so they all emphasize on the statistical modeling to derive this so-called spatial relationship knowledge. So in this book, here I include a general outline here. We start from several motivations to different case studies in geostatistics and spatial regressions, respectively, and talk about some potential challenges in this realm. So we treat spatial as special, so which make it hard to kind of perfectly describe all this spatial knowledge in a statistical language. In this chapter, we discuss the motivations for us to introduce GeoAI to handle the spatial things as special, such as varying AI architectures for the modeling of geospatial representations, dealing with different GIS datasets like the raster data and vector data, and also the challenge of multimodal features in spatial tasks, and how the notion of neighborhood will affect our model design, and moreover, to capture the complex spatial effects, such as the spatial dependence and the spatial heterogeneity using AI and neural network. So with that, we provided in this book basically 2 cases to just showcase how GeoAI can benefit the spatial prediction. The first one is spatial interpolation in geostatistical tasks. So for traditional case, we propose the pipeline as in Kriging interpolation for a very representative case. But now we find that generative AI, for example, the generative adversarial neural network and some newly proposed foundation models can help us overcome the statistical assumptions in some traditional geostatistics. And it has potential to branch a research direction for the so-called deep geostatistics. And we provided in this chapter an empirical case on the super resolution of wind and solar radiation, which you go from a lower resolution image to a high resolution dataset. As you can see here, some of the GeoAI-based methods, especially the generative AI methods, are getting more realistic and accurate results compared to the traditional one, like this aerial to point kriging. They are more detailed spatial patterns and higher prediction accuracies. Another field in the spatial prediction use the spatial regression model, which is another large family of modeling to learn these statistical associations among variables and also consider the spatial effects. So in this book chapter, we also propose that graph convolutional neural network as a new AI method can somehow replicate this spatial regression workflow while don't have the limitations such as the econometric assumptions, statistical assumptions, which makes it capable of modeling more complex associations for us to utilize in the future. So in this chapter, we mentioned several cases within this direction, including this case I'm showing you in this slide, modeling and prediction of the Airbnb price data. As we can see, some of the graph neural network-based methods can generally give us a much better prediction accuracy in terms of the correlation results. So to very quickly sum this up and lay out some challenges, here we believe the future of spatial prediction methods definitely needs to embrace AI, but at the same time adding the concerns from the GeoAI perspective, such as how to enhance the transferability and generalization across the regions and across the time status. And also, how to enable reasoning across spatial variables, spatial features, and also across spatial scales. And also to mitigate this geospatial uncertainty that have been long-standing in the realm of spatial prediction, how to utilize some methods to increase the replicability, mitigate the bias, and ensure the trustworthy and fairness of spatial prediction for sure. Well, that's all I have today, and thanks again for the opportunity to share, and looking forward to more insights to come with the handbook of the GeoAI here. Thank you.
Thank you so much, Dee, for this very informative presentation on a topic which is not simple. Generally, my students don't like so much this statistic part, but it's very, very important. And you explained it very well how it is important for the geospatial field, that it's exactly what is interesting for us, not only and simply AI, but also the application to the geo, so to the space, and how to take into account this concept of geospatial that you highlighted so well. Thank you so much for your very kind presentation. And now I go to the last one. So the last but not the least one is Dr. Jingyi Hu, who will present spatial cross-validation for GeoAI. Is an associate professor. Dr. Hu is an associate professor in the Department of Geography at the Buffalo University. He's also an adjunct professor in the Department of Computer Science and Engineering at UB and an affiliate professor of the UBAI and Data Institute. His major research area is in GeoAI. More specifically, his research integrates geospatial data, spatial statistics, and AI methods to understand human environmental interactions and to address some of the challenging problems facing our society, such as those related to natural disasters, public health, and ecosystem conservation. He holds a PhD from the Department of Geography at the University of California, Santa Barbara. He received his Master of Science, bachelor degrees from East China Normal University, and is the author of over 50 peer-reviewed articles in top journals and conferences. So, Dr. Hu, over to you.
Okay, thank you very much, Maria. So I will share my screen now. Okay, hello everyone. So my talk is about chapter 10, spatial cross-validation for GeoAI. So cross-validation has been widely used in GeoAI research to evaluate model performance. So very often we divide our training data into multiple folds. So here is an example of 10-fold cross-validation. So we can use 9 folds of the data for training and 1 fold for validation. And we iterate this process and get an average score. While effective cross-validation could lead to an overestimate of model performance on geographic data. So if we visualize our training and validation data spatially we may see some of those random cross-validation split data. They are spatially close to each other, such as these two data points here. So a model that is trained using the data points here, they can be considered as has already looked into the nearby validation data. So spatial cross-validation is a spatially explicit cross-validation approach that splits data spatially rather than randomly. And different spatial cross-validation methods have been developed, but they exist in literature across multiple disciplines. So in this book chapter, we summarize the main spatial cross-validation methods and also conduct 2 case studies to understand the effect of different cross-validation strategies on the obtained evaluation scores. So before we move further, I would like to first clarify that while we are talking about spatial cross-validation, here it does not really always provide a more suitable assessment of model performance than random cross-validation. It really depends on how the trained model will actually be used. There are 2 common situations in GeoAI research within error prediction and between error prediction. So in the first case, our trained model will be used to make predictions at those red locations within the same study area. And in such a case, random cross-validation can be more suitable because the trained model will actually be used to make predictions at locations that can be spatially close to the training data. In the second case, the trained model will need to predict into new areas which can be spatially adjacent to the training data, like this case, or can be a bit further away. And in such a case, spatial cross-validation can be more suitable because it better simulates the way the model will actually be used. So there are 4 major methods developed in the literature. These are clustering-based spatial cross-validation, grid-based, geo-attribute-based, and also spatial leave one out. And a number of software packages in both R and Python have also been developed to implement these spatial cross-validation methods. So let's look at these methods one by one. The first one is cross-validation, spatial cross-validation based on clustering. So basically, we use a clustering method such as k-means to spatially split our data. So in this example here, we have 3 clusters, and then we can use, for example, 2 clusters for training and 1 cluster for validation. And here are the software packages that implement this clustering-based spatial cross-validation. The second approach is a grid-based spatial cross-validation. So intuitively, we can use a spatial grid to divide our study area. So in this case, we have a 3x3 grid, and we have 9 grid cells. We can use 8 of them for training and 1 for validation. The next one is geo-attribute-based spatial cross-validation. So basically, we can use a geo-attribute such as county name or city district name that often exist in geographic data sets that we work with. And we can use some regions, for example, in this case, there's 3 regions for training and then another region for validation. The fourth approach is called a spatial leave one out. Basically, this is really a spatial extension of the classic leave one out cross-validation. So we add a buffer zone to the area where the validation data is located. And the data in this buffer zone, they will not be included in the training process. So through this, we further separate the training data and the validation data. So now we know these 4 major spatial cross-validation methods. We can look at 2 case studies. So in the first case study, we try to predict a neighborhood level domestic violence rate in the city of Chicago using a random forest model based on socioeconomic attributes. The data set is from our previous study. We use exactly the same model, but we use different cross-validation strategies. So we use random cross-validation. In this case, we have a random tenfold cross-validation. As you can see in this figure here, the data points, they are spatially mixed with each other. We also have a clustering-based cross-validation. Here we use 10 clusters here. Grid-based cross-validation, we have a 3x3 grid here. Geo-attribute-based cross-validation, in this case, we are using the community name in the city of Chicago, and also spatial leave one out. So here we use a buffer distance that is 5 percentile of all the neighborhood distances. So let's look at the result here. So we use two evaluation metrics, R-square and root mean squared error. And for the first row, we have the random cross-validation. And for the following 4 rows, we have 4 spatial cross-validations here. So overall, we can see that random cross-validation gives us the highest evaluation scores. And this can be expected because the training and the validation data, they are spatially close to each other. The evaluation numbers of these 4 cross-validation approaches, they are different, but we cannot really see which one is more suitable or less suitable. It depends on how the trend model will be used to make predictions. So let's say if the trend model will be used to predict into new area defined by administrative units, we may want to use a geo-attribute-based spatial cross-validation. If it will be used to predict into new areas that is more similar to a grid, then maybe a grid-based spatial cross-validation is better. In the second case study, we look into a different city, New York City. We look into a different public health problem, obesity prevalence. We use a fully connected neural network model here. Again, we fix the model architecture and we look at different cross-validation strategies. And here is our result. So in this case, we can actually see a larger difference between random cross-validation and the spatial cross-validation. And we think one reason is because this data set has a higher level of spatial autocorrelation compared with the previous domestic violence data set in the city of Chicago. But overall, this pattern holds. So basically, we have higher evaluation scores in random cross-validation compared with spatial cross-validation. So conclusions for this book chapter. So we talked about a spatial cross-validation, which is a spatially explicit approach for assessing model performance. We talked about 4 major methods for spatial cross-validation: clustering-based, grid-based, geo-attribute-based, and also spatial leave one out. We conducted 2 case studies based on real-world data in 2 different US cities and using 2 different machine learning models. And finally, spatial cross-validation is not always more suitable than random cross-validation for GeoAI research. It depends on how the trend model will be used to make predictions. So that is all. I would like to thank my students who really did a lot of hard work for this chapter. The code for this book chapter is shared on GitHub. And that is all. Thank you very much.
Thank you, Dr. Wu. Very impressive work, very interesting, very useful for all of us also for knowing what to do for the validation. And yes, now I want to ask all of you if you want to come on the stage. So if you can show you again, because I want to ask the last question, probably because we have a very short time. And I addressed the question to Gao, but obviously also if the other people wants to add something, you are welcome. So Gao, I want to understand what advice would you give to researchers or practitioners looking to contribute to or to explore the field of GeoAI based on the insight provided in your handbook?
Yeah, thank you, Maria. Yeah, this is a very important question because the rapid evolution of the AI technologies. So no matter it is traditional machine learning or deep learning or latest foundation model, I think we need to keep our domain scientific research question in mind. So really, what scientific question, what other global challenges we are trying to address using the latest AI technology, and keep our human in mind, also the community, in the loop, and to achieve some of those United Nations Sustainable Development Goals. Yeah, that's my take. How about others? Yeah.
Thank you. And is there someone else who wants to add? Yes, Samantha, please go ahead. Yes.
Yeah, I totally agree with what Song said. I think that we have an opportunity here to really collaborate across so many fields. And I think it's an opportunity that we almost have to really. And I love that, because the more we work with others, the further we're going to be able to forward these goals for sustainability. So I encourage, if you're a computer scientist, pair up with, a geography geek, and vice versa, and natural resource specialists, and really bring the groups together to collaborate on these big issues that are facing society today.
Thank you, Sam. Yes, I agree also with you. Thank you so much, and thank you. Oh, I see that the Dr. Zhu has something to add.
Yeah, I just want to quickly add one thing here is I think also the handbook mentioned those advancing rapid development in the AI as a general domain. So as geographers and researchers in specific domain, I think the advancing of these models might speed up some of the research, but at the same time, we need to keep in mind whether that it's actually being more accessible or actually being more sustainable as researchers in a specific domain to access, for example, the large model, foundation model that are maybe hard to train, require larger data, and all those kind of challenges that just put on all the researchers within this field. Yeah.
Yeah, thank you, Dee, also for speaking about this foundation model, because we have well in mind, together with Rohini and Andrea, this point, and in fact, one of the next event will be related to that. But Dr. Hu, what you wanted to add?
Yeah, just want to add to the discussion. I think in our GeoAI book, we also talked about these two major areas of research, right? Methodological GeoAI research, and also the use of GeoAI research to address societal challenges. So I think for interested researchers, you can really choose either one of them or even both of them, because both of them are important, right? Those methodological research, they provide very important foundations for us to develop solutions. When we actually use those methods to address societal challenges, we really make a positive impact for sustainable achievement. And this process also will come back further inform our methodological development. So yeah, both of them are very important. So I think our GeoAI community can really benefit from more researchers joining this effort.
Thank you. Thank you a lot to all of you. So first of all, I want to congratulate, because it was an excellent idea to put together these brilliant researchers and prepare this collaborative book, which is available for all of us. And I already started reading it. I have to say, I didn't finish, but yeah, I'm looking forward to read all the chapters, because I believe that all of them are very amazing. So thank you so much for the work that you have done. And now I think that it's time to give the floor to Rohini for the closing. Thank you. Thank you again.
Thank you.
Wow, my brain is still processing. What an exciting time to be part of the geospatial landscape, right? It feels like the future is already here. And personally, I can't wait to see some of these great solutions to be operationalized and fully utilized and learn more about them. And I concur, Maria. I would like to thank all our incredible speakers for this fascinating session, and also our audience, of course. Last but not least, thank you, Maria, for co-moderating this event.
Yeah, thank you, Maria.
We really appreciate your leadership on this. Before we close, I would also like to remind all of you of a couple of upcoming events as part of the GeoAI Discovery. On the 1st of March, we will have a webinar on geospatial frontiers, navigating the future with generative AI and foundation models. I'm really looking forward to it. And on 12th of March, we also have one on new climate change initiative, focusing on high-resolution land cover map from the European Space Agency. And of course, I also have to mention our workshop at the AI for Good Summit, which will be on the 30th of May. It will focus on navigating GeoAI, plotting the course for future education. I'm particularly excited about this workshop. It's organized under Dr. Maria's leadership with participation from academia, private sectors, and the UN. We will be showcasing the deliverables of the 4 international working groups, which were set up following the 2023 GeoAI Summit. And it highlighted the need for educational frameworks in GeoAI. So stay tuned for all of those exciting developments in GeoAI. And I thank you all again for your participation. And with this, let me give the floor back to Anna.
Thank you for participating in today's AI for Good session. We hope you've learned something new, innovative, and engaging in today's event. We now encourage you to continue the conversation on the live video wall in the neural network. Here you can ask questions, like and comment, share links, complete the poll, connect with interesting profiles, or speak one-on-one using the chat and video function. We invite you to explore the lobby, try the smart matching quiz, visit the virtual exhibits, poster boards, the eShop, and build your personalized AI for Good program. Let's shape the future of AI for Good.
The AI for Good Global Summit, convened by ITU, recognizes the joint responsibility of governments, the private sector, United Nations agencies, academia, and others to ensure AI reaches its full potential while preventing and mitigating harms.
And it's a moment that calls for action. And today I'm calling on each of you to use this summit to help the world to better understand what kinds of regulations, what kinds of guardrails we need to put in place right now. So together, let's make it innovative, let's make it safe, and let's make it responsible for all. Thank you very much.